Hello, and welcome to today's session, ECL Watch, Redefining Progress. What is this presentation about? In this presentation, we will delve into 5 key topics that showcase new and improved features within ECL Watch. Why is that important? Our goal is to empower you, the user, to explore and harness these new features effectively. By doing so, you'll be better equipped to excel in your roles within HPCC systems. These enhancements in ECL Watch are designed to streamline your workflows and enhance your productivity. About your presenter. Allow me to introduce myself. I'm Kunal Aswani, a software engineer and member of the HPCC Systems development team. Alongside my colleagues, Gordon Smith and Jeremy Clements, we are dedicated to ensuring that ECL Watch is always at the forefront of innovation. Our commitment is to deliver powerful tools and features that are always redefining progress within HPCC systems. So what are the topics? Snapshot queries in Roxie. Snapshot queries provides a window into a specific point in time, allowing us to analyze data as it existed at that moment. Leveraging snapshot queries in Roxie can aid in historical analysis, trend identification, and understanding data dynamics. We'll discuss the benefits, use cases, and implementation best practices for incorporating snapshot queries into our workflow, and your workflow for that matter. Logging. Efficient logging practices are integral to the troubleshooting and optimization of any system. In our context, logging within Roxie queries offers insight into query execution, performance bottlenecks, and potential errors. It's not limited to Roxie. It can be used across the entire HPCC systems platform, and we'll delve deep into the types of information we should be logging, techniques for effective logging, and how this data can guide our optimization efforts. Cost estimation. Optimizing performance involves considering the cost of resources, such as computing power and memory. By accurately estimating the cost of queries, such as Roxie, we can make informed decisions about query optimization strategies. We'll explore methods for estimating resource consumption, interpreting cost metrics, and making trade-offs between query speed and resource usage. Metrics for efficient data retrieval. Measuring query performance is crucial for assessing the impact of optimization efforts. We'll identify key metrics to track, such as query execution time, data transfer rates, and cache hit ratios. These metrics will provide a quantitative basis for evaluating the effectiveness of our optimization usage strategies and making data-driven decisions. And finally, hotspot identification, an upcoming feature. While this topic is on the horizon, it's worth mentioning that identifying and addressing hotspots, areas with disproportionately high query loads, is a critical aspect of performance optimization. By proactively identifying these areas, we can preemptively allocate resources and prevent performance degradation. Stay tuned for more on this exciting topic in future discussions. And if you look on your screen, we have one reminder for you. I want to remind the users that the topology section will differ between cloud, as you see here, versus the bare metal. And ECL Watch will always adjust based on what you are running on. And where better to start than snapshot queries in Roxie? Roxie introduces a notable new feature, snapshot queries. This functionality empowers users to perform data analysis with a laser focus on specific moments in time. Enhanced decision-making and data-driven insights. By introducing snapshot queries, Roxie takes a significant step toward enhancing decision-making and enriching the data-driven insights delivered to users. So why are snapshot queries important? They provide temporal data analysis. Roxie snapshot queries enable users to conduct temporal data analysis by capturing a precise snapshot of the dataset at any given moment. Consistency and reproducibility. These queries ensure unwavering consistency and reproducibility in data analysis, allowing users to recreate results with ease. Point-in-time insights. With snapshot queries, users gain valuable insights into the data's state at a specific point in time, offering a unique perspective on data dynamics. Reduced complexity. Snapshot queries simplify data analysis by providing a stable and static data set for querying, reducing the complexities associated with real-time data. And enhanced decision-making. Organizations can make more informed decisions using Roxie snapshot queries, harnessing the power of historical data to drive strategic choices. How to perform snapshot queries in Roxie. You can do so by accessing your HPCC cluster page. You'll begin the process by navigating to said HPCC cluster page using ECL Watch. Look for the section labeled Queries, identified by the globe icon on the left-hand panel. Choosing a Roxie query. Within the Query section, select a specific Roxie query that you intend to work with. In my example, for instance, we consider the example city by state search. And you'll navigate to the test pages, which is highlighted in red right now on the screen. Within the Test Pages tab, you'll find the sub-tab labeled Form, and you'll click on it. Normally, this will be there by default as the first page. You'll start by inputting query information in the Form sub-tab. You'll need to input relevant information that your query requires for execution. Let's use an example where we're interested in data related to our city, Boca Raton, our county, Palm Beach, and our state, Florida. After inputting the necessary details, you'll click on the button for each field to confirm the input. Then you'll move to the drop-down on the bottom left and choose the option Create Work Unit so that you may proceed. Finally, you'll click on the button to submit so that you can send your query request. At this point, the Roxie snapshot query process is set into motion. The system will capture and retrieve the data as it was at a specific point in time that you selected for analysis. And here we can see the results. With the Roxie snapshot query initiated, you gained the ability to analyze the data in its state at the chosen moment. The snapshot provides a window into the past, enabling historical analysis and insights. And as you can see, we got back 5 results for the state, Florida, city, Boca Raton, and county, Palm Beach. In summary, performing a Roxie snapshot query involves a structured series of steps, starting from accessing the HPCC cluster page to inputting query details and initiating the query itself. This process grants us the valuable capability to analyze data at any specific moment, facilitating historical analysis and data-driven insights, all while being in an easy-to-use form within ECL Watch. In wrapping up our exploration of snapshot queries, we're presented with an exciting realm of possibilities that extends beyond conventional data analysis. The facets we've uncovered underpin the significance of this innovative approach. We have new dimensions of understanding data. Snapshot queries introduces us to novel avenues for understanding data. By peering into specific moments, we transcend the static view and delve into dynamic insights that uncover hidden narratives. We're able to track changes with precision. The precision offered by snapshot queries revolutionizes our ability to track changes. We no longer skim the surface. Instead, we dive deep into the intricacies of transformation over time. Refining strategies effectively. As we harness historical data, we gain a powerful tool for refining strategies. Past successes and setbacks guide us toward optimizing our approach for more effective outcomes. We're able to navigate data complexity. Snapshot queries are our compass through the maze of data complexity. They enable us to navigate intricate relationships and dependencies, illuminating the path to clarity. They provide comprehensive insight. That insight, delivered by snapshot queries, ensures we never view data in isolation. Every piece contributes to the bigger picture, granting us a panoramic understanding. We're able to optimize and improve in performance. Utilizing snapshot queries paves the way for optimization and peak performance. By identifying bottlenecks, inefficiencies, and untapped potential, we fine-tune our operations. And our ability to embrace data-driven decisions. Snapshot queries empowers us to embrace data-driven decisions with confidence. Armed with historical context, our choices gain depth, precision, and informed foresight. As we conclude, the journey through snapshot queries leaves us with an imperative: to evolve our approach to data analysis. This new dimension beckons us to explore, refine, and innovate, all while staying firmly rooted in the rich insights that history can provide. With snapshot queries, our potential to drive impactful change takes on a new and dynamic form. And now we'll move into the logging section. We want to introduce a new interface featured in the latest version of ECL Watch. This enhanced feature offers users several convenient ways to access important functionalities. It's available through the Work Unit Details page. The new interface is accessible through Work Unit Details, providing users with a streamlined approach to managing their work units and tasks. The Topology section, which is located in the Logs tab. Users can access this interface via the Topology section in the Logs tab. This feature simplifies the process of monitoring and managing system resources and log data. And additionally, we've introduced our newest portion, the ZAP report form, which serves as a key component of this new interface. It plays a vital role in retrieving log records from the backend log tool and provides all the same features as the log viewer we will showcase in the Logs tab. So what is it? The primary function of this interface is to retrieve log records from a backend log tool efficiently. It will empower users with the ability to filter log data on specific criteria, enhancing their ability to troubleshoot and analyze system activities effectively. I'd like to note that using this feature may require prior configuration of the backend log processor, and we recommend setting up this configuration ahead of time to fully leverage the capabilities demonstrated in this demo. To access it, begin by navigating to the Topology option on the left-hand pane, and then select the Logs tab at the top left. Here we've selected the topology, and we'll move into selecting the Logs tab. This Logs viewer retrieves records from the backend log management tool. which we previously configured prior to this presentation, and is essential so that you may view logs in your ECL Watch. Now, let's proceed to the log filtering process. You can filter logs by container name, allowing you to view logs specific to the ECL Watch container. The container name for this one is ECL Watch. Alternatively, you can filter by class, which categorizes logs as audit events, error events, informational events, progress, or warnings. Let's say that you're interested in viewing error logs that are reported by ECL Watch. You can select the error option, as I've done on the screen, and apply the filter. We can then submit this request. The log viewer will display any reported errors, and oh look, I found an error. That was quick and easy. Now, let's say that you'd rather search all log entries associated with a particular work unit. You can enter the desired work unit or job ID in the respective fields and apply the filter. Here, I already have a work unit pasted into my search filter. Great. This provided me with all the relevant log entries linked to the target work unit ID that I was searching for. Additionally, you can download selected log entries as a CSV file. And to even further narrow down your search, you can filter logs based on the content of the log message using a wildcard syntax. For instance, you might want to see all log entries containing the term output. After applying this filter, you'll be presented with filtered log set matching your criteria. So here on the screen, our job ID is already posted, and we're using the wildcard output to find any log messages with the phrase output that are associated with this job ID. Great, we were able to get about 10 to 12 results that show both the job ID that we need and the output message for that log. The log viewer interface offers even more accessibility by being seamlessly integrated into each work unit through the work unit details page. Within the ECL section, you can easily select a specific work unit as demonstrated on the screen. Here, I've already selected my work unit. Once you've selected your work unit, you'll find the embedded logs viewer conveniently located under the logs tab. It'll be the third from the right-hand side. What's noteworthy is that this embedded viewer provides you the same comprehensive functionality as the general log viewer. You're able to search using time, wildcard outputs, or any of the other features that we showcased in the previous section. This integration ensures that you can effortlessly monitor and analyze log data specific to your selected work unit, enhancing your workflow efficiency and facilitating detailed troubleshooting when needed. Moving into log ZAP reports. We're particularly thrilled about the ZAP reports logging feature, as it empowers users to engage more effectively with log data, enabling productive discussions and problem solving. It provides enhanced sorting. The ZAP report dialog introduces advanced sorting capabilities, making it effortless to organize log entries. This unique and efficient sorting mechanism simplifies your navigation through log data, ensuring you can quickly find information you need. Time-based searching. In the ZAP report form, you can effortlessly search logs by specific dates for relative time ranges. This feature streamlines the process by pinpointing relevant information, helping you track events accurately based on when they occurred. And precision logline searches. For a highly targeted approach, you can initiate searches directly from specific log lines within the ZAP report. This functionality ensures you can swiftly locate critical log data without unnecessary hassle. And we provide component filtering. The Zap report form also offers component filtering, allowing you to refine your log search based on specific components. This focused approach enhances your ability to perform in-depth analysis and troubleshoot effectively, ensuring that you can quickly identify and address issues as they arise. Here on the screen, you can see the zipped analysis package, aka the Zap form. In the bottom section of the Zap form, you'll be able to see a new section called Log Files, where we will have all of the features that I just discussed, and you'll be able to submit that Zap report with those specific criteria mentioned. Let's move into cost estimation. In this portion of our journey, we will be going through navigating cloud estimation in the cloud. We unveil the pivotal role of ECL developers in controlling cloud costs. Discover how cost-efficient design choices are key to balancing performance costs and developer time. Dive into the empowering features of HPCC systems, facilitating cost-efficient design decisions. And let's explore the pivotal benefits of cost estimation in cloud services. Smart resource provisioning leads to optimal utilization and reduced waste. Informed decision-making ensures design choices align with budgetary objectives. And we can achieve a harmonious balance between performance and cost through cost-effective estimation. Let's move into the 3 types of cost estimation for cost management. We have execution cost, which unveils the expense of executing work units, graphs, and subgraphs. File access cost, which delves into the charges associated with data operations, like reading and writing. And storage cost, which helps us to understand the cost of hosting data in the storage plane. In this slide, users are able to see the execution cost and file access cost in the work unit details area. You can see it highlighted with the orange square around it. Let's move into execution and file cost access. Execution cost management. Users are able to perform efficient execution cost management, which involves a careful consideration of nodes. Key nodes contributing to execution costs include workers, compilers, and agents. You can dive into the granularity of cost analysis from graphs to subgraphs and activities. Then we have the file access cost segment. These insights allow for users to understand the influence of data operations like reading and writing costs. This helps users to anticipate future enhancements to cost reporting, including separate values for the at-rest and file access costs. And now we'll move into the storage cost optimization. The focus area is hosting data in storage. Some of the exclusions may be temporary or spill files, and the granularity can be seen in the logical files summary page. With storage costs, users are able to unlock insights into optimizing storage costs for hosted data. Users can examine exclusions and inclusions when calculating storage costs. And we can further explore the accessibility of storage cost insights in the logical file summary page, as you see here on the screen. This is where you'd be able to identify your storage costs. Now, there are some caveats to cost calculation, and users should recognize those that are associated with this. Cost values provided are approximations and help to guide decision-making. Factors impacting accuracy include external file access, caching, underutilized nodes, and many more. Cost estimation within Thor. Diving into managing costs within Thor components for effective resource utilization. We have two considerations: soft cost limits and hard cost limits. We need to understand that the concept of cost limits, soft limits being those that can be overridden by the max cost ECL option, and hard limits, those that are absolute and cannot be overridden. We also offer support for Thor jobs using the Job Guillotine feature. You can discover a powerful risk mitigation tool, which sets limits on job costs to prevent runaway expenditures, ensuring predictable and controlled cloud spending, something I'm sure every manager is looking forward to. And now we come to the upcoming features of cost estimation. Anticipating that we have enhancements such as cost tracking from Roxie and historical file cost insights. And that's not to exclude Azure HPCC cache support and compilation cost tracking as well. Evolving cost calculations. Users will be able to see cost calculation with an emphasis on accuracy and user-friendly reporting. Now, let's move into metrics for efficient data retrieval. Introducing a new enhancement to the ECL Watch interface. Metrics emerges as a dynamic and versatile feature that will revolutionize the way users interact with performance data within the HPCC systems ecosystem. Replacing our traditional Graphs tab, Metrics ushers in a new era of monitoring and analysis, providing users with an intuitive and comprehensive toolset to delve into the intricacies of their cluster's performance and gain invaluable insights. This transformative upgrade will provide users the empowered ability to dive deeper into the understanding of their system's health and efficiency, ultimately driving informed decision-making and optimization with their data processing endeavors. Here you can see the new interface that I just mentioned. Let's take a deeper look into the Metrics tab, where we'll find the linear timeline, a seamless, intuitive timeline for tracking system performance over time, ensuring you stay informed about the peaks and troughs of your data processing. The metrics filter. This provides precision at your fingertips. You can zoom in, hone in, and focus on specific segments of the graph, eliminating data clutter and delivering pinpoint accuracy. The property details. Dive into the inner workings of performance elements, uncover intricacies, dissect processes, and gain a comprehensive understanding of your system's dynamics. And last but not least, the graph section, something that you are very familiar with. You'll be able to visualize data in its most illuminating form. Charts, trends, and correlations will come alive, offering vibrant insights that guide your decisions and illuminate your path forward. Metrics empowers you to harness the pulse of your system, make strategic choices, and elevate your data processing endeavors to unprecedented heights. And now on to our final portion of the presentation, a coming soon feature, hotspot identification. When hotspot identification does go live, our outlook is that we are able to identify the critical path, enabling us to strategically allocate the resources and optimize the budget for utilization. By pinpointing activities with potential cost escalation, such as data volume, resource-intensive steps, dependency on expensive resources, and performance risks, we can proactively manage expenses. This approach involves thoughtfully distributing resources, closely tracking costs, seeking optimization opportunities, and mitigating performance-related risks. Ultimately, Our focus on cost estimation empowers us to enhance query execution efficiency, maintain budget control, and achieve successful outcomes in our Roxie query projects. And we're very excited for when hotspot identification does go live. As we wrap up our presentation, we encourage you to actively participate in our Q&A session. Please be sure to use the Q&A section to ask any questions you may have regarding the topics that we've covered today. If you'd like to screenshot some of my reference links or revisit specific slides, you may do so now, or you can download the entire slide deck for future reference. So without further ado, let's begin the Q&A segment in the designated Q&A section of this presentation. Thank you.